Hey everybody, welcome back. Well, I'm trying the camera at a little different angle here right now. And as you can see, I have the amplifier turned on and warmed up and found out some interesting things. So this is going to be a good video. The first thing I want to show you here is this thing right here. This is that little box that takes the speaker's signal, this goes in parallel with the speakers, and it converts it to a line level output, and it actually provides isolation and impedance matching. However, it turns out all that hum we were hearing was not from the YouTube algorithm, even though it was amplifying it. That hum is being generated by this. I can connect this with no load on it, nothing on it, just put this into the camera, and this thing is like an antenna. These are really high-end isolation transformers in here. And what I didn't realize is they act like little, not even microphones, they act like little receivers. Just turning the overhead lights on in the room or just turning on the bench power itself generates an incredible amount of hum. And I can hold this out in the open like this and it still picks it up. So I'm going to have to figure out some kind of a grounding scheme for this. The whole thing was I wanted to give isolation to it because right now as this thing stands, if we have like a Carver amplifier or something that can do bridge mode and has the isolated grounds, this is totally isolated between left and right and between input and output. And I want to maintain that, but I want to find a way to properly shield this to get rid of that hum. So until I get that fixed and get that problem worked out, we probably won't be using this to record any more music for a while. We'll go back to the old microphone system. I have the amp warming up, and we're going to go over and check some voltages. We're going to see if this overhead camera is a little bit better. You'll probably see the back of my head with my balding head, but hey, I don't care. The good Lord only made so many perfect heads. The rest of them he covered with hair. That's what a buddy of mine said to me one time. But anyway, let's check this out, and then let's pass a signal through it, and let's see what kind of performance we can get out of this thing. We're going to do some tests. So first thing, amplifier is on. And the first thing I want to do is I want to check for balance between these tubes right here for the cascode. So what we're going to do is, let's see, the meter is here, but I don't know if you can read it. It's pretty tiny there, isn't it? Let's just see how this works. I'll go back to a different view if this doesn't work out when I look at the clip. But we're going to check this balance pot right here. And we're going to measure between here and here and see if we have 0 volts between here and here. That's going to tell us if these two lines are balanced with this pot. So I have these little test points underneath, so all I got to do is get on them. And you can see it's like 100 millivolts or a couple millivolts. Right now it's floating around. And remember, there's 350 volt supply there, so, plus or minus a volt, half a volt, it's balanced. Let's check side 2 and get on that. That one's 100 millivolts. And at this point in the game, these pots are so sensitive, even though they're only, 100 ohm pot or whatever, you can only, the balance is going to be within 500 millivolts, it's right on. They're balanced. So that's good. Now let's check the bias and balance of the tubes, of the outputs. So let's start with the bias voltage of the one side. You can see 58 millivolts. And that's what we want, according to our schematic. And on this side, I'm just checking the one tube. 58 there. And then if we check balance, we go from the one to the other, and we're within 1 millivolt. And we go on this side, we're within less than a millivolt. So tubes are balanced and they're properly biased. Okay, let's now go over to our setup, and I'll just kind of pan you around here on the camera. If you look over here, I have the left channel being monitored by this THD meter, and I have the right channel is going to be on this THD meter right here, and we're feeding it with our signal generator up here, and we're going to actually look at the waveform on the scope here. So let me see what I can do. I'm going to get one channel and then the scope on here. And we're going to feed a 1 kilohertz signal, and I want to get about 2.8 volts RMS. That's going to equal about 1 watt. So see where I'm at right now. I'm right on it, 2.8. Okay. And you can see the blue channel and the yellow channel, they're directly on top of one another. So the channels are perfectly balanced. And much to my shock and amazement, can you see what the THD is right there? 0.05. I mean, for a tube amp, that's unheard of. And here's the weird thing. If I go over to this one, you can see it's 0.03. So it's almost half of that other one. And this is something that we're going to work on in this video. If I change the frequency, so let's say let's go to 20 hertz. I don't know if this meter can pick it up. Yeah, it can't pick it up. But you can see 20 hertz is kind of the cutoff, like I said, of the meter. But you can see over here, everything's staying flat. I mean, it's still 2.8. We're at 20 hertz. And if I just go up a little bit, let's go to like 50 hertz. I think it'll start picking it up. There we go. And it jumps around a lot, but if you see, I have to set the filtering and everything a little different on the meter, but you can see just as is, it's staying around 0.3, it's jumping between 0.2 and 0.4, something like that. But if you go over to the other channel, once again, it's way higher. It's like 1.5%. And it's across the board like this. Now, as you get up to higher frequencies, let's go to 10 kilohertz. So there's 10 kilohertz. Waveform looks good. And you can see THD drops. It's down to 0.03. And it matches now. 0.03. See that? So it's frequency dependent. So whatever is going on with this, with the distortion, it's frequency dependent. So let's think about that for a minute, because we have to troubleshoot this. I want them to match. Now, mind you, all of these numbers to me are good on both sides. You would never hear the difference between 0.06 and 0.03. But it means that something's working differently between both of them, between the two channels. So the name of the game now is to try to figure out what is causing that and why. Why everything's working perfectly at high frequency, but not at low. I think it's probably going to have something to do either with the negative feedback or some kind of a problem, harmonic or microphonics or something in these tubes. And that's kind of what we want to do. So I'm going to do the simple thing first before I go crazy. I mean, the voltages are all good. I did verify our power supply and everything. Voltages, and as you can see, the calibrations are good. So what I'm going to do is I'm going to swap these tubes over to here and these tubes over to here, and we're going to see if our problem moves. So let's get a baseline once again. I'm going to go back up to 1 kilohertz. Okay, and we're back to 0.03 on that side. Let's see, 0.03 over here, and 0.05 something over here. All right, and let's just rule out the test equipment, okay? So I will disconnect this meter. Well, let me show you what I'm doing so you can see. We'll do this live. So I'll go down here. Sorry about all the camera mounts and stuff in the way. So I'll take this one here and this one here. I'll move this one over to here. I'm just doing this real quick. Somebody commented that I say that real quick. Now, I am doing it as quickly as I can. Okay, swapped them around, and you can see now the problem moved. It's still, now it's 0.03 on this side, and it's 0.05 on this side. So it's not my test equipment. Has nothing to do with any of that. Okay, I've switched the meters back to how they were. I'm going to turn the power off and let this cool a little bit because these suckers are hot. And then what I'm going to do is I'm going to swap these tubes between the two channels, and then we'll rebalance them. We'll check them for balance, rebalance them, and see if the problem moves. Okay, the tubes are swapped around. Let's plug it back in, turn it on, and we'll have to check our balance again to make sure that it's not too far out. Like I said, if it's within a 0.5 volt, we're good. And just give it a minute. Okay, let's see where these things are going to settle. Okay, that one's out a good bit, so we're going to have to touch that one up a little bit. And you'll see how touchy this thing is. So let's move. See that? Just barely touching it. And I mean, this is a 3-turn pot. There you go. I'm just going to leave it like that. That's close enough. 60 millivolts. Let's go on this side. And it's out even more. So okay, that'll do. All right, now remember the right side was the one that had the higher distortion. So we're going to check now. I'm going to just kind of focus you over there a little bit. And if we see anything real significant, I will zoom you in on it. Okay. And we can see we still have higher distortion on the right than we do on the left. So on the right, we have 0.06, and on the left, 0.03. So I don't know if I can get everything in zoom here or not, or in the field. There we go. So that's not good. It did not move. Okay. So now what we're going to try is see if maybe there's something going on with the 6SN7s. We'll swap those around. Okay, the 6SN7s are swapped around. And we're going to now try it again. Give it a second to warm up. Have to wait for that. Again, these were all beta matched tubes, or gain matched tubes. So I wouldn't expect them to be the problem, but you never know if some of them have microphonics or something. So let's turn this back on. And right where we were still. 0.059, 0.03. So definitely still a difference. So let's, we'll check and swap out our big output tubes now. Okay, I have those swapped. Let's turn the power back on, and we are going to have to rebias and rebalance these tubes. So let's hook up the meter here. So let's balance this out. And you can see how close they are. This is a 10 or 15 turn pot on this one. Okay. There. That one's done. And then we'll go back and touch up the bias once we get it balanced, because they're probably going to be a wee little bit out. That's really close. Let's check the bias. That's a little hot, so we'll turn that down. Right there. And we'll take this one, turn it down. This one needs to go up a little bit. There we go. Okay. Well, it would help if I turned off the sound. Never mind. Okay, balance, good. Bias, a little bit lower yet because I had a signal on. Can't believe that. I didn't turn off the signal generator. Right there. Back to the balance on this one. Touch that up maybe a little bit. There we go. And then bias. That's a little bit hot, so we'll turn that down just a little. There we go. Okay. And back on. And what do you know? Look what just happened. The 0.05 went to this side, 0.03 went to this side. It's the tubes. So apparently one of these tubes is noisy. Probably has some microphonics or something like that. But it is a tube problem. Okay, I think I figured it out. One of these tubes has a microphonic problem, and it's mechanical. It's actually not just electronic, it's mechanical. The amp's on right now. I'm going to turn the signal off. But I'm going to hold the mic next to each one of these and tell me if you can see, or tell me if you can tell one different than the other. Here we go. Here's number one. Here's number two. Here's number three. Here's number four. Hear how these three have like a thump, but this one rings? Hear how it rings? That's a bad tube. Okay, what I've done now is I swapped these two tubes around when I put them back. In other words, the one that was noisy, that had that ring to it, I put it on this side. The other one I put on this side. I rebalanced it and rebiased it. Let's zoom out now. You are zoomed out. Good. Let's apply a signal. And what do you know? They're both down around, well, this one's at 0.04. This one is at about the same. That balanced it out. So I had to do a little tube shuffle, but there you go. And these were supposed to be matched tubes if you look for what it's worth. This is the whole thing when you talk about getting matched tubes. That doesn't always mean that they're going to play well together, because it depends how they match them. But like here's 3 of the 4. You can see right there the numbers. I don't know if it's focusing or not, but You seeing that? And then here's the other one. I just couldn't hold all four at the same time. They're all the same numbers. See? So I don't know. But obviously something's different about them. But either way, we're splitting hairs because that's such low distortion. But the channels are identical, so they should perform identical. I mean, it's the way it should be. Okay. All right, it's another day, and we're going to run the frequency analysis. And you can see I just got the thing set up and did a test run. So let's go over here and zoom in. And let's take a look at what happens. I think you can see what's going to happen. It's going to do that again, I hope. So the amp's pretty well warmed up. So let's hit start. Isn't this exciting? All right, so the red line shows the phase shift, and let me go in and set this. The offset always goes to 3. I don't know why on this thing, but it auto scales even when you don't want it to. All right, so here we go. So you can see there's 0 degree phase shift if the red line were there. The red is the phase, the blue is the amplitude. So you can see how flat this amp is for gain. So it's got a flat gain from 20 hertz all the way up to 20 kilohertz. That's the maximum range this little scope can do. As far as phase, it's going between plus and minus 15 degrees. And that's to be expected. That's what's going to happen on this. We could play around with the feedback a little bit more, but I'm already kind of where I want to be with it. So that's just kind of where it is. It looks good. So let's move to the other channel now. So I'm going to switch, and I'm going to put the signal from the other channel into the analyzer now. All right, I don't know if you saw that because I'm so zoomed in. And let's hit the measure again. Let's see here. All right, and this is the other channel. Now, in a perfect world, this will all fall back right on top of where the other channel was. So we'll take a look at that here, and I'll have to set the scale again because it always changes. I wish you could make the scale not automatically adjust, but it just does on this software. Okay, and you can see it's generally the same thing. And let me go in and scale it again. Just change this. You don't really have to do this, but I like to have the 0 degrees in the middle of the scale. It just makes it easier to see. And you can see, once again, identical. Same kind of phase shift characteristic. Both channels are identical. Both are the same gain. They're both sitting, and you can see here 22 dB. Again, that's a relative dB based on the drive signal and everything. So you're getting about 22 dB of gain through the amplifier is what it's saying. And both channels are identical, and both of them are flat. So that's all very good news. Okay, so now what I'm going to do is we're going to go to these two channels here again. And I'm going to turn off the signal generator. Disable that right now. Let's see here. I'm going to connect it back up here to the other signal generator. And I'm going to go back on this to our 2-channel scope. And as you can see, we'll set those. That should get us where we need to be. Okay. And what I'm going to do right now, we're going to go back. Okay, get this scaled up a little better. And you can see how the two waveforms just fall right on top of one another. It's very good. Okay, so now what we're going to do is we're going to switch over to a square wave. And you can see there's our square wave, and that looks pretty good. We'll stretch it out, and then we'll kind of move these two channels apart from one another so we can see what they're doing. And that's not bad. And we can see the one channel actually is controlling it a little bit better than the other. I also have this 1 microfarad film capacitor. And if I take it and just put it across the speaker terminals on the one side, let's see what it does. Gives it a little more ring, but it handles it, snubs it pretty quickly. Right? There we go. And then we'll try the other channel, see if it handles it any differently. About the same. So that's not bad either. So I think what this is showing is you could see the one side rings a little bit more than the other. And I don't think that has anything to do with the... No. Okay. So that might be why we're getting a little more distortion on one channel than the other, because the feedback doesn't seem to be working the same in both channels. So we'll have to look into that. Maybe one of the resistors is a little bit out of tolerance or something. But all in all, the amp is doing really well. Okay, I have got the thing hooked back up. You can see, let's zoom into the scope, and we're going to drive it into clipping, and we'll look at how many volts we get at clipping, which will tell us our watts, right? So about 17.8, around 18 volts is going to be 40 watts per channel, and that's probably where we're going to start seeing the clipping. So let's turn it on. And you can see right now, well, we're at 18 volts, 17.8 here and 17.9, 18 is kind of bouncing around. And if I go up a little bit more, we'll bring it into clipping. Hold that thought. Okay, duty calls, you know. So let's take this into clipping. Right there, that's right there. I'm flat topping on both sides, and we have 18.4, 18.6. It's kind of bouncing around on there, so it's a little, maybe 42 watts. And my distortion is 0.8% on the right channel and about 1.0% on the left channel. So they are a little bit different. Remember, it's those tubes. But heck, with flat top clipping, I'm still only getting 1% distortion on a tube amp. I don't know what else you could ask for. So I'm going to say this is done. This amp is done. I'm not going to mess with it. I'm happy with it. I'm getting full clipping at 1.5 volts. Actually, 1.51 is where we're seeing the flat top. So we'll say 1.5 volts RMS, which is good. So that's a pretty good signal gain. And I'm happy. Okay. So in lieu of my little breakout box, because I have to fix it, I'm just going back to my old Zoom microphone, my little divider network here going across the speakers. And we're just going to record it that way. And what I'm going to do is I'm going to play Stranger Danger, and we will record it, and we'll see how it goes. So let me get this started. And let me start the song. So that's it for right now. Such a long project, you know, and but I'm very happy with the results. It just goes to show that you can calculate things all day long, but just sometimes you have to do some experimenting. You have to test it and make adjustments as you go along. You can kind of get yourself in the ballpark, but and the more experienced of a builder you are, which I'm not, the better you can get it first time around. But I would say I'm very happy with the way this thing turned out. This is something I could put up in my living room and listen to all day, and my ears probably would never get tired of it. And that might actually be what happens. I may actually bring this upstairs once I get a nice case built for it. I'm going to have to put build a case. I'm going to probably do a finger jointed surround around the outside. I'm just going to have a power switch on the front, and maybe I may not even put a light on it. I don't know. We'll see. We'll just see what happens. But I wanted to keep it minimalist on the case so that you could look at the woodwork. I'm going to probably use some sort of an exotic hardwood or something. And there's my computer beeping through this thing. But anyhow, that's where we are. Now, I do have another project that I have to get on a bench. That's why I want to get this one off of the bench. And maybe we'll do a shop video with the woodworking and everything. We'll see. Let me know in the comments if you like that. But this scope back here, this Tektronix 5054B, it's not booting anymore. And it's a pretty common problem with these. And we're going to fix that. I'm going to do a video on it. And then I'm also going to show you some other things with it that I'm going to do to kind of maybe upgrade it a wee little bit. But that's it for right now. So again, I wish you all peace, joy, happiness, and good health in your lives. And we'll see you all very soon. I'm excited that I can be back on the bench here a little bit more than before. This is not as crazy at work. And I hope all is going well for all of you as well. So we'll see you again real soon. Take care, everybody. Bye-bye.